Now in the last part of this question we've got to find in terms of m and u the magnitude of the impulse that A exerts on B in the collision. Now that impulse I'm going to mark in as an arrow to the right, and I'm going to label it as I. This is a blow, if you like, that B receives from A. Now to work out impulse you should know this basic equation, that impulse always equals change in momentum. In other words, the momentum, the final momentum, mv, minus the initial momentum, mu. So if I'm going to find out what I is, I need to consider B. So if I consider B, I've got to take a positive direction. That's the first place that I find that a lot of people go wrong. They don't realize that they're dealing with vector quantities, and in that case sign matters. Now because I acts to the right, it seems sensible to take the positive direction to the right. So my impulse is going to be plus I, or just simply I. And it's going to equal the final momentum, mass times the final velocity. Now the problem is, at the moment I haven't got the final velocity as such. I've got from the previous part that the final velocity was 3ku minus 4u, but we're given that k equals 7/3. So by substituting 7/3 for k, we can work out what the final velocity will be. So it'd be 3 times 7/3 times u minus 4u. Well, these 3's cancel and you've got 7u minus 4u, which is 3u. So we've got B moving to the right with a speed of 3u. Alright, so when it comes to the final momentum, mass times velocity, the mass is m and the final velocity is 3u, and it is in the positive sense. So we've got mass times 3u. Then we've got to subtract the initial momentum. So put the minus in and we look at the initial momentum. So the mass is m, and then we've got to times it by the initial velocity. So what is the initial velocity? Well, we know that it was moving with 4u to the left, and we've selected positive direction to be to the right. So we must be careful here to write minus 4u. Now that's the place that I feel that people are going to trip up on, so just take care on that point. Okay, so if we work this out, we've got 3mu and we've got plus 4mu, and that makes a total impulse of 7mu. And that is the answer essentially to the question. But I would like to point out that you could have got exactly the same answer if you had considered A. And in some questions when you're asked impulse, it's quite often simpler to select your object, your particle that you're going to apply the impulse on. So I'll just demonstrate this here. There'll be an equal and opposite impulse acting on A when they collide. So let's just mark that in here as I. Now because I acts to the left when we're looking at A, I'm going to select to the left as being positive. So when it comes to doing the impulse equation, we've got I equals the change in momentum. So we look at the final momentum, mv. We know that the mass is km, or in this case 7/3 m, because k is 7/3. So that's the mass. We look at the final velocity and we can see that we've got u going towards the right in the positive sense. So that's going to be just times u. Then we have minus the mass again, so km, 7/3 m, multiplied by the initial velocity. And the initial velocity, well, it was 2u, but you'll notice it's going in the opposite sense to the plus direction here. So the velocity would be minus 2u. So put that in there. So you've got to be careful on that part. So what have we got? We've got 7/3 mu. And here we've got plus 14/3 mu. So when we add them together, we've got 21/3 mu, and 21/3 is the same as 7 mu. Our answers agree. Okay? So whatever way you do it, the magnitude of the impulse is going to be 7 mu. Well, that brings us now to the end of question 3.